Welcome to the deep dive. Today, we're pulling back the curtain on something that, well, influences our daily lives more and more, yet often feels like a bit of a black box. Artificial intelligence.
It really does.
I mean, think about it. You've got these perfectly tailored recommendations on streaming services or sophisticated fraud detection systems looking after your finances. AI is sort of silently shaping our world.
It's everywhere.
But have you ever really stopped to wonder what it takes to bring these incredibly complex systems to life? What's the actual rigorous process behind building AI that's not just powerful, but also responsible, secure?
Fair.
Yeah.
Getting that right is the real challenge.
That's exactly our mission for this deep dive. We're going to try and demystify the entire life cycle of an AI solution.
From start to finish.
Right. And our main guide for this journey is a key industry standard, specifically Chapter 3, Part B of the AAISM Official Review Manual. Think of us as your instructors, maybe, helping you navigate each critical step.
We'll break it down.
By the end of our conversation, you, the listener, should have a pretty comprehensive understanding of the huge effort and the really thoughtful considerations that go into developing and managing AI you can actually trust.
Hopefully you'll get those aha moments.
Exactly. Those moments about why AI behaves the way it does and what it really takes to ensure it works for us, with us, in a way that builds confidence. So let's get started.
The AI life cycle, a holistic framework.
Okay, so we hear about AI all the time in the headlines, but we rarely get a peek, really, behind the curtain at the structured, almost architectural process needed to develop and manage it responsibly.
Yeah, it's not just about coding something up quickly.
Not at all. It's far from just coding. It's this intricate, continuous journey from an abstract idea, really, to a fully functioning and, importantly, evolving system.
And that evolving part is key.
It seems like it. And this journey is fundamentally different from building, say, traditional software, right?
Absolutely. What's truly fascinating here, and I think often misunderstood, is that the inherent dynamism of AI, its ability to learn, adapt, and sometimes even unpredictably evolve, that's precisely what makes those traditional sort of linear software development models, well, inadequate.
Inadequate how?
Well, imagine building a house where the rooms suddenly decide to rearrange themselves based on who walks through the door. Sounds absurd, but traditional software, once it's built and tested, generally has a largely fixed behavior. You know what it's going to do.
Right, it's predictable.
Exactly. But AI systems are often designed to be fluid. Their behavior can shift, sometimes significantly, based on new data they encounter, new interactions, or even subtle changes in the environment they operate in.
Ah.
So this core difference, it really demands a specialized life cycle, one that's absolutely essential for proper governance and risk management, embedding continuous oversight and learning right from the start.
That's a really powerful analogy, the house rearranging itself. So the good old system development life cycle, the SDLC we all learned about, it isn't quite enough for AI because AI is more like a living, evolving thing than just a static piece of code.
That's a great way to put it.
It feels like the challenge is maybe less about writing the perfect initial code and more about managing this ongoing process that has to respond to constant change.
You've really hit on the core challenge there. The traditional SDLC, I mean, it's incredibly robust for many software projects, don't get me wrong, but it often assumes a relatively linear progression, right?
Yeah.
And a fairly fixed set of requirements.
Yeah, gather requirements, design, build, test, deploy.
Exactly. You gather requirements, you design, develop, test, deploy, and then you maintain. It's often sequential, like a waterfall or maybe agile iterations, but usually aiming toward a stable product. But for AI systems, that kind of stability is often elusive by design. They're built to learn, adapt, and improve, which means their behavior isn't static. It can and often will change based on new inputs or shifts in the operational environment.
Okay, so it needs a different management approach.
Precisely. It necessitates a much more fluid and continuous management approach. We need to embed things like continuous learning, ongoing monitoring for, say, performance degradation or the emergence of bias, and the ability for rapid adaptation throughout the entire process, not just as a one-time development effort.
Not just upfront.
Not just up front. This continuous feedback loop is exactly why prominent organizations like the OECD, the Organization for Economic Cooperation and Development, have outlined a very specific AI lifecycle.
Right, I've seen that OECD framework referenced in the ISIC materials we're using. It's definitely not a straight line, is it? It looks much more like a continuous loop.
It is.
Can you help us understand why that cyclical nature is so critical for AI and maybe walk us through those core stages they outline?
Absolutely.
Yeah.
And the OECD model, it fundamentally highlights that AI development and management isn't a one-and-done deal.
Right.
Nor is it this rigid linear progression. It's a continuous iterative loop precisely because of AI's dynamic nature. It ensures that a whole array of activities, from the technical development side to crucial ethical oversight and risk management, are seamlessly integrated and, importantly, revisited across the AI system's entire lifespan.
Revisited. Okay.
It acknowledges that an AI system is never truly finished. It's more like it's constantly evolving and requires ongoing care and attention.
Like tending a garden rather than building a bridge.
That's another good analogy.
Yeah.
So let's break down the core stages of this continuous cycle. You'll quickly see how each one feeds into the next and often back again. It all begins, as you'd probably guess, with plan and design. This is the initial conceptualization phase. It's where you strategically define what the AI is intended to achieve, why it's genuinely needed, and crucially, how it aligns with the broader organizational goals and values. It's really about setting that foundational blueprint, deciding the purpose and the parameters before any code gets written.
Makes sense. Laying the groundwork.
Exactly. Once that conceptual foundation feels solid, our attention has to turn to the lifeblood of AI. Collect and process data. AI models are, quite simply, only as good as the data they learn from.
We hear that a lot.
And it's true. This stage involves meticulous gathering, rigorous cleaning, and precise preparation of that crucial fuel. It's a painstaking process because, as we'll definitely discuss more, that old saying, garbage in, garbage out, is profoundly, almost brutally true for AI.
Okay, so data's next. Then what?
After the data is as pristine and ready as we can make it, we move into the actual construction zone. Build and/or adapt models. Here, the core AI algorithms are developed. They're rigorously trained on that prepared data, and then they're continually refined. This is where the AI truly starts to learn patterns and establish its internal logic.
The learning part.
The learning part. Following the building phase, we enter test and verify. This is a critical, really rigorous evaluation phase. It's about ensuring the AI performs exactly as expected, achieves the desired accuracy, and, maybe most importantly, complies with all the established ethical guidelines and safety requirements.
So not just does it run, but does it run right and responsibly?
Precisely. It's about verifying its real-world capabilities and its trustworthiness. Once it's verified and validated, the AI is ready to be made available for use deploy. This is Launchpad, where the AI is carefully introduced into its operational environment, ready for real-world interaction and to begin delivering its intended value.
Okay, launch time. But it doesn't stop there, does it?
Not at all. Deployment isn't the end. In many ways, it's just the beginning of the next phase. Operate and monitor. This phase involves continuous oversight, ongoing maintenance, and constant performance tracking. Because AI systems are dynamic and can drift over time, their management has to be just as dynamic. This is where you catch unforeseen issues and ensure continued performance, fairness, and security.
That ongoing care.
Ongoing care. And finally, when an AI system has served its purpose, or maybe it's no longer viable or effective, we move to retire decommission. This isn't just about pulling the plug. It's the responsible, secure, and ethical shutdown of an AI system, ensuring data privacy is maintained and no unintended negative legacies are left behind.
Wow, that cyclical nature really hammers home the point that AI isn't some static product you just build and then forget about. It truly sounds like a living system, constantly needing care, attention, adaptation.
That's exactly the mindset needed.
So beyond just making something that works, how does this continuous loop help ensure that the AI is actually responsible throughout its entire existence?
That's the absolute crux of it. The ultimate goal isn't just a functional AI that performs a task well. It's about deploying an AI that is fundamentally secure, fair, transparent, and accountable.
The trustworthy aspect.
The trustworthy aspect. And this commitment to responsibility requires embedding ethical considerations, comprehensive risk assessments, and rigorous governance into every single phase of that cycle we just walked through.
Not just at the end.
Definitely not. It's not an optional add-on or some checklist item performed right before deployment. It has to be a fundamental design principle that guides all the subsequent stages. For instance, you're thinking about potential biases right from the planning stage. You're ensuring data privacy is paramount during collection. You're rigorously testing for fairness when building the model.
It's baked in from the start.
Baked in. This continuous oversight helps to proactively manage and mitigate risks like data bias and model drift, which, if you leave them unchecked, can emerge or evolve over time and lead to significant unintended harms. Without this holistic, embedded approach, even a technically brilliant AI could inadvertently create or exacerbate societal problems.
That's a powerful and really critical distinction. Understanding this overarching framework, it truly helps you, the listener, grasp the sheer scale and, frankly, the profound complexity involved in responsible AI deployment. It's clearly not a simple switch you flip, but a carefully orchestrated, continuously managed, and ethically guided journey. This whole framework really sets the stage perfectly for everything else we're going to dive into as we explore each specific phase in more detail.
Phase 1, plan and design.
So we've laid out the big picture, that continuous loop of the AI lifecycle. Now, where do we even begin with a brand new AI initiative? It all starts, as you said, with plan and design.
Yeah.
It might sound straightforward, maybe even obvious, but this phase feels absolutely foundational. Almost like drawing the intricate blueprints before you even think about laying the first brick for a skyscraper.
That's a perfect analogy.
If you get this part wrong, the whole structure could end up being unstable or maybe even collapse later on.
Absolutely. And this immediately raises a crucial question. What exactly needs to be planned and designed when we're talking about AI? Because it's far more profound than just drafting some technical specifications.
Right. It's not just about the tech specs.
Not at all. At its heart, this phase is about deeply aligning the proposed AI solution, not only with the organization's values and strategic goals, but also, quite critically, with broader societal expectations and ethical norms. And you need to do all of that from the absolute outset.
Okay, societal expectations too. That makes perfect sense. So let's break down the essential elements then. What goes into defining the AI solution in this critical initial stage? What are the key questions you absolutely must answer?
Well, first and foremost, you need to establish the crystal clear purpose and objectives of the AI.
The why.
Exactly, the why. And you'd be surprised how many AI projects, even with massive investment and brilliant technical teams, they flounder. Not because of the technical challenges necessarily, but because of fundamental failure right here at this very first step. A lack of crystal clear, measurable objectives.
Just wanting AI isn't enough.
It's definitely not enough. This isn't about vaguely wanting to use AI. It's the absolute necessity of defining what specific problem the AI is intended to solve, why it's needed over perhaps more traditional solutions, and precisely how it aligns with the organization's strategic goals and its core business problem.
Can you give an example?
Sure. Like, are you trying to optimize supply chains to reduce delivery times by a verifiable 20%? Is the goal to enhance customer service by automating, say, 70% routine inquiries within the first year? Or maybe it's to detect financial fraud with a 95% accuracy rate while also reducing false positives by 15%.
Specific and measurable.
Specific, measurable, achievable, relevant, and time-bound smart goals, essentially. Without these, an AI project can quickly lose direction, suffer from scope creep, or just plain fail to deliver any tangible, measurable value. It's truly about understanding the what and the why before you even start thinking about the how.
Okay, so purpose and objectives first. What else?
Then we really need to move into deeply understanding the context and requirements. This involves a thorough comprehension of the operational environment where this AI will actually live and breathe.
Where it will operate.
Right. And the specific needs and maybe even behaviors of its future users. The complex existing regulatory landscape it absolutely must navigate, like GDPR or healthcare regulations, and any crucial ethical considerations that might arise.
Ethical considerations up front.
Absolutely upfront. This isn't just a technical exercise. It's about proactively identifying potential impacts, both positive and negative on individuals, maybe specific demographic groups, or even the environment.
Like the loan application example.
Exactly. If you're conceptualizing an AI for loan applications, you must, from day one, consider anti-discrimination laws and think very carefully about how the AI's decisions might impact different socioeconomic groups. This deep early understanding is frankly your best defense against unintended consequences that could prove disastrous if they're only discovered much later.
Got it. Context, requirements, ethics. What's the third piece?
And finally, during this planning phase, there's the conceptualization of the architecture and components. This is where you start to design the high-level structure of the AI system itself.
Blueprint.
The blueprint. What are its various constituent parts going to be? How will data flow into it and out of it? What fundamental model architecture, like a neural network or a decision tree, might be suitable? And critically, how will this new AI system seamlessly integrate with the existing IT infrastructure and the current business processes?
Integration is key.
It's vital. This early architectural thinking is absolutely vital for ensuring future scalability, robust security, and long-term maintainability. A well-thought-out architecture provides the essential skeleton for the whole system, making sure it can grow, adapt, and remain secure without needing constant, costly re-engineering down the line. It's really about designing for the foreseeable future, not just the immediate problem.
That sounds like an incredible amount of foresight is needed right at the beginning. So why is this comprehensive upfront planning phase so profoundly important? It really seems like it's where you bake in all those responsible AI principles right from the get-go, not trying to tack them on later.
Precisely, you've nailed it. This initial planning and design phase is arguably the single best and often the only truly cost-effective opportunity to identify and mitigate potential risks before they become deeply ingrained and incredibly expensive, maybe even impossible to fix within the system later.
Easier to fix on paper.
Exponentially easier and cheaper. This proactive approach includes addressing potential biases in the very design of the solution, foreseeing and planning for privacy concerns, and shoring up security vulnerabilities from the absolute ground up. This approach aligns perfectly with established principles like privacy by design. But for AI, we really extend it to a comprehensive, ethical AI by design.
Ethical AI by design. Tell me more about that.
Well, it means that true ethical principles, specific transparency requirements, and clear accountability mechanisms must be meticulously built into the very core design of the AI.
Not just a checklist.
Far from it. It's not a mere checkbox exercise you tick off at the end. It's a fundamental design principle that has to guide all the subsequent stages of the life cycle. Let's take that example of an AI making critical, life-altering decisions, say, in healthcare diagnostics or financial lending.
High stakes.
Very high stakes. Right from the start, you need to embed explainability requirements, meaning how will this AI be able to communicate why it arrived at a particular decision? If it's that loan application AI, how will you ensure you can transparently explain to an applicant why their loan was denied or why their interest rate is what it is? Building in this level of explainability and auditability from the conceptual stage is fundamentally different and far more effective than trying to somehow reverse engineer it later on.
Okay, that makes a lot of sense. What else is critical in this planning phase?
Another absolutely critical aspect, and one that's often underestimated, is diverse stakeholder engagement.
Getting everyone involved early.
Exactly. It is paramount to involve a broad, inclusive range of stakeholders very early in this process. This means bringing in not just your technical development teams, but also legal counsel, maybe dedicated ethics committees if the organization has them, compliance officers, various business unit leaders who will actually use or be impacted by the AI, and crucially, potential end users who will interact with the system.
Why is that so important?
Well, this multifaceted engagement ensures that a wide array of perspectives are considered, which is invaluable for helping to uncover potential unintended consequences or overlooked impacts that maybe a purely technical team might miss.
Different viewpoints catch different things.
They really do. Beyond that, it fosters crucial buy-in for the project across the organization, making its eventual adoption and long-term success far more likely. User feedback, for instance, shouldn't just start at deployment. It should be seen as vital input from these very early design stages.
Right. And the last piece of planning?
And finally, this phase is about establishing a clear blueprint and robust governance. This means meticulously defining clear roles and responsibilities for everyone involved in the AI initiative, establishing transparent communication protocols, setting up a robust governance structure that will oversee the entire AI's journey.
The roadmap and the rules.
The roadmap and the rules. This comprehensive blueprint serves as the definitive guide, setting the stage for a smooth, well-managed development process. It ensures that the project consistently adheres to its defined standards, its legal obligations, and its ethical expectations. Furthermore, this is where you outline your detailed data collection and processing strategy, which forms the essential basis for the next crucial phase we'll discuss. This foundational work in planning acts as the strategic anchor, ensuring consistency, accountability, and direction throughout the AI's entire lifecycle.
That's incredibly insightful. The planning and design phase truly is where the foundation for a trustworthy and impactful AI gets laid. If you, our listener, ever find yourself wondering why an AI system makes a particular decision, or maybe questioning its fairness, the answers often begin right back here, how it was conceived and designed in this very first stage.
The roots are often there.
It powerfully underscores why your critical thinking about AI needs to start long, long before it's deployed or even built. It's about understanding the core intent, the underlying assumptions, and the initial ethical framework that guides its creation from the very start.
Phase 2, collect and process data.
Okay, so we've meticulously mapped out our plan. We've got our blueprint for the AI. We know exactly what problem it needs to solve. And we've set our ethical and governance guidelines. Now, here's where it gets really interesting and, frankly, utterly foundational. The next crucial step in the AI lifecycle is all about the data.
Everything comes back to data.
It seems so, because without the right data, AI is just, well, it's a magnificent algorithm waiting for a meal, isn't it?
That's a perfect way to put it.
It's like a master chef meticulously gathering, cleaning, and preparing every single ingredient before even thinking about firing up the stove. The ingredients have to be right.
Exactly. And this brings us to a fundamental question. How do we make sure the data feeding our AI is not just plentiful, volume isn't everything, but also perfectly fit for its intended purpose, ethically sourced, and securely handled throughout its entire journey?
A tall order.
It is,
Yeah.
because that old adage, garbage in, garbage out, isn't just a cliche in the world of data. It is profoundly, almost brutally true for AI. If your raw ingredients are tainted, incomplete, or inappropriate, no matter how skilled the algorithm or how powerful the computing, the resulting meal won't just be bad, it could actually be harmful.
Let's dig into that garbage in, garbage out principle a bit more. It sounds simple on the surface, but why is data quality so absolutely imperative, and what are the real-world consequences if it's neglected?
Well, it's not just imperative. It's really the cornerstone upon which all AI models are built. AI models, they learn patterns, relationships, even subtle biases directly from the data they are fed.
They learn what they see.
They learn what they see. So if this data is biased, maybe it reflects historical inequalities, or it's incomplete, inaccurate, inconsistent, or even just irrelevant to the task, the AI will inevitably learn and replicate these flaws. And that leads to unreliable, unfair, or even actively harmful outputs.
Like AI hallucinations.
That's a great example. Consider large language models that sometimes hallucinate, providing confidently stated but completely false or misleading information. This can often be directly traced back to issues with the quality, the representativeness, or perhaps inherent biases within their vast training data sets.
Or discriminatory outcomes.
Absolutely. Or think about a hypothetical hiring AI that, because it learned from historical hiring data reflecting past biases, might inadvertently screen out perfectly qualified candidates from specific demographic groups. These aren't just theoretical issues. These are real-world consequences of poor data quality, leading to misidentifications, incorrect predictions, and discriminatory outcomes that can have significant societal or business impacts.
Okay, so the risks are huge. How do we combat that? What ensures the data isn't garbage?
To mitigate these risks, we have to rigorously ensure data integrity. This involves implementing systematic measures and controls to guarantee that data remains accurate, complete, consistent, and valid throughout its entire life cycle, from the moment it's acquired until it's eventually archived or retired.
The whole journey.
The whole journey. This includes things like robust validation checks at every point of data entry, sophisticated error correction processes, and maintaining the absolute authenticity of data as it moves through various systems and transformations. It's really a continuous commitment to preserving the trustworthiness of your information.
And security. Privacy must be huge here, too.
Oh, absolutely. Data security and privacy are completely non-negotiable and paramount. Given that AI systems often deal with vast amounts of sensitive or personal information, protecting that data from unauthorized access, breaches, or misuse is utterly critical.
How do you manage that?
Well, it necessitates implementing robust security controls at every single stage. During its initial acquisition, throughout its storage, whether on-premise or cloud, during processing, and when it's actively used or perhaps even shared. We're talking about things like advanced encryption techniques, granular access controls, and applying data minimization principles, meaning only collecting and retaining what is strictly necessary for the defined purpose.
Minimizing the footprint.
Exactly. Furthermore, compliance with stringent data privacy regulations, think GDPR in Europe, CCPA in California, and other relevant frameworks globally, is not just a legal requirement. It's really a fundamental ethical imperative. Data must be pseudonymized or anonymized wherever feasible, and critically, handled with explicit consent from individuals, especially when dealing with personal data. This builds trust and ensures accountability.
So we've established the absolute need for quality, security, and integrity, which sounds like a massive undertaking in itself. But what kinds of data are we actually talking about here? AI seems to consume all sorts of information from really diverse sources.
You're right, AI definitely thrives on a mosaic of information. We generally categorize data for AI into a few broad types. First, there's structured data. This is the kind of data that's highly organized and formatted in a predictable, consistent way. That makes it easily searchable and analyzable. Think of it like a perfectly organized filing cabinet or a spreadsheet.
Databases, financial records.
Exactly. Traditional relational databases,
Yeah.
spreadsheets, financial transaction records where information is neatly arranged into columns and rows with predefined fields. Then we have unstructured data. And this is a much vaster, often messier, and more complex category. It includes things like raw text documents, emails, customer service chat logs, research reports, social media posts.
Images, audio, video.
Right. It also encompasses rich media like images, audio recordings, and video files. This type of data lacks that fixed format, meaning it requires far more sophisticated processing techniques, often involving things like natural language processing, NLP, or computer vision, to extract meaningful patterns, insights, or sentiment for an AI to learn from.
Much harder to work with.
Definitely more challenging. And increasingly, especially with the explosion of smart devices, we see sensor data and IoT, Internet of Things data. This is information streamed directly, often continuously, from connected devices like smart home sensors, industrial machinery, wearable health trackers, or autonomous vehicle sensors.
Real-time data streams.
Exactly. This data provides potentially powerful real-time insights, but it also poses unique challenges due to its sheer volume, its velocity, the incredible speed at which it's generated, and of course the significant associated privacy implications of constant pervasive monitoring. Each type of data requires specialized handling and processing before it can be effectively used to train an AI model.
That's a lot of different kinds of inputs, each with its own quirks and challenges. So once you have the data collected and maybe categorized, what are the key processes involved in actually managing it to make it AI ready? It definitely sounds like there's much more to it than just dumping it all into a massive database.
You're absolutely right. It's a highly structured and multi-layered process needed to ensure the data is truly optimized and trustworthy for AI use. It really all starts with data acquisition and provenance. This isn't just about getting the data, it's about deeply understanding how it's sourced. Is it internally generated by an organization's own operations, or is it acquired from reliable third-party vendors?
Knowing where it came from.
Precisely. It's absolutely vital to meticulously track data provenance, knowing exactly where the data originated, when it was collected, and how it was originally intended to be used. This detailed information, often called metadata or data about data, is critical for everything from understanding potential inherent biases to debugging complex models later on, ensuring compliance, and even preparing for future audits. This includes recording specific details like who the original data creator was, who the designated data custodian is, the exact origination point, and even broader subject keywords for context.
Okay, tracking its history. What else?
Then there's the necessity of formalizing processes through things like data processing agreements, DPAs, and standard operating procedures, SOPs. For any data handling, but especially when interacting with third parties or even just across different organizational departments, formal agreements are indispensable. These DPAs precisely spell out how data will be processed, transformed, and shared, ensuring strict legal compliance and consistent operational standards.
And the SOPs.
Similarly, SOPs provide detailed step-by-step instructions for every aspect of data handling, collection, cleaning, storage, access, deletion. This ensures consistency, efficiency, and unwavering adherence to the established data governance principles.
Which brings us to data governance.
Exactly. Data governance principles themselves are critical. This involves implementing clear policies and comprehensive frameworks for things like data ownership, who is ultimately responsible, granular access control, who gets to see what, specific usage guidelines, how can it be used, and clear data retention policies, how long do we keep it.
Setting the rules of the road for data.
That's a good way to think about it. It establishes a robust system of accountability, precisely defining who is responsible for data quality, security, and compliance throughout its entire life cycle. This overarching governance ensures that data is treated as a strategic asset, managed with the highest degree of care and integrity.
You mentioned visualizing data flows earlier.
Yes, a very powerful and often illuminating tool is data flow mapping. This involves creating a visual representation of the precise movement of data through an entire AI system, tracing its journey from its raw input sources all the way to its final output or use.
Like a flowchart for data.
Essentially, yes. Imagine a simple diagram. Raw data from a customer database flows through an integration layer, then into the AI system for processing, and finally generates an output, maybe a recommendation that goes to a customer-facing application. This meticulous mapping is crucial for several interconnected reasons.
Such as?
Well, first, it provides unparalleled transparency, allowing you to understand exactly where data goes and how it transforms at each step. Second, it aids significantly in risk identification, helping you pinpoint potential vulnerabilities, points of data loss, or areas of unintended data exposure. And third, it is absolutely vital for compliance, verifying that data handling adheres to all relevant regulations and internal policies at every single step of its complex journey.
Seeing the whole path helps manage it.
Absolutely. And finally, building on provenance, metadata management is absolutely essential. This is the practice of meticulously creating and maintaining detailed data about data.
More than just the source.
Oh, yes. This doesn't just mean generic descriptions. It includes highly specific attributes of data sets, such as unique IDs, descriptive titles, their core purpose, identifying the data creator and custodian, detailing where it originated, its physical or logical storage location, how frequently it's updated, its last modification date, its format, like CSV or JSON, and crucially, any specific rights and restrictions governing its use.
Wow, that's detailed. Why is all that necessary?
This rich metadata is vital for truly understanding the data's context, making it reusable across different projects, making the debugging of AI models far more efficient, and fundamentally enhancing the data's traceability and ultimately the AI's explainability. It's really the invisible backbone that supports responsible and well-managed AI.
Data truly is the fuel for AI, isn't it? And understanding how it's collected and processed and all these rigorous measures needed to ensure its quality, security, and privacy, it really helps you, the listener, appreciate the hidden complexities and the potential pitfalls in the AI systems you use every day.
It's not magic.
Not at all. It empowers you to ask better questions like, where does this data come from and how is it being handled? It's not just about what the AI does, but critically, what it learns from, and how that learning process is managed right from the foundational data layer.
Phase 3, build and/or adapt models.
Okay, so we've got our meticulously defined plan, our comprehensive blueprint for the AI. We've got our squeaky clean, ethically sourced, securely managed data ready to go. Now we're stepping into what many people probably think of as the real engine room of AI, the build and/or adapt model phase.
Yeah, this is where the algorithms meet the data.
This is where the magic, or maybe sometimes the profound mystery, begins to unfold as these algorithms truly start to learn and take shape.
Right. And what's truly fascinating here, and maybe often misunderstood by those outside the field, is that building an AI model isn't just a straightforward coding exercise. Not by a long shot.
More complex than just writing code.
Much more. It's a complex process involving making crucial, often quite delicate, decisions that profoundly impact the model's ultimate fairness, its transparency, and its resilience when it faces real-world challenges. This is precisely where the theoretical understanding of algorithms meets the messy reality of actual data. And the stakes are incredibly high, because the choices made right here in this phase directly influence the AI's real-world behavior, its reliability, and its broader societal impact.
Okay, that makes perfect sense. So let's delve into the model development process itself. What's that iterative cycle of training, validation, and testing all about? It sounds like a constant feedback loop, a process of refinement.
It absolutely is a continuous cycle of refinement.
Yeah.
And it's essential for creating robust and reliable AI systems. It typically begins with training. This is essentially the model's education phase.
School for the AI.
Kind of. You feed the carefully prepared data that we spent so much time discussing in the previous phase to the chosen AI algorithm. During this process, the algorithm learns patterns, identifies relationships, and extracts features from the data. It's a bit like a student diligently studying textbooks and working through examples to build their knowledge base.
Okay, so it learns from the data, then validation.
Right. Following this initial training, we move to validation. This is where we use a separate data set. And crucially, this is data the model has not seen during its training to tune the model's internal parameters, its hyperparameters. And importantly, we use it to prevent a critical problem called overfitting.
Overfitting, what's that exactly?
Overfitting occurs when a model becomes too specialized in the training data. It essentially memorizes the noise and the specific quirks of that particular data set rather than learning the underlying generalizable patterns.
So it knows the training data too well.
Exactly. The result is a model that performs exceptionally well in the data it was trained on, but then performs poorly or unreliably when it encounters new, unseen data in the real world. The validation set acts as a sort of practice exam, helping us adjust the model so it generalizes well to new situations.
Got it. Training, validation, Then testing.
then testing. Finally, we transition to testing. This is the ultimate independent assessment. The model is rigorously evaluated on yet another completely unseen dataset, one that was specifically held back just for this final check.
The final exam.
The final exam, exactly. This phase measures its real-world performance, its accuracy, and its ability to generalize its learning to truly novel inputs. This is where you really confirm whether the AI can truly perform its intended task reliably and accurately when faced with the unpredictability of a live environment.
And it's not just about accuracy, right? You mentioned interpretation.
Right. Beyond just getting the model to perform accurately, there's also the crucial aspect of calibration and interpretation. Calibration involves fine-tuning the model's outputs to ensure they are statistically reliable and well-aligned with real-world probabilities. For example, if a medical diagnostic AI predicts a 70% chance of a certain condition, you want assurance that prediction accurately reflects a true 70% likelihood in the real world.
And interpretation, especially for those black box models.
Exactly. Interpretation, especially for complex black box models like deep neural networks where the internal workings are hard to follow, means trying to understand why the AI made a certain decision. This is where the emerging field of explainable AI, or XAI, comes into play. The goal of XAI is to provide insights into the AI's reasoning process. This fosters trust, it enables crucial human oversight, and it allows for auditing or challenging decisions, particularly in critical applications like loan approvals, medical diagnoses, or even in the criminal justice system.
So if we're performing all these steps, diligently training, validating, testing, calibrating, interpreting, what are the ideal qualities we should be striving for in a well-built AI system? What does true success look like beyond just, solving the initial problem?
That's a great question. Success in AI development extends far beyond just functional capability. Our source material, the ISACA manual, really highlights that we're striving for an AI system that embodies several key interconnected qualities. These really form the bedrock of responsible AI. First, and perhaps most obviously, high reliability and accuracy. This means the model consistently performs as expected. It makes correct predictions or decisions with minimal errors and high confidence in its outputs. It's about precision, consistency, and dependability in its core function.
Does what it's supposed to do reliably.
Right. Second, the AI must be demonstrably fair and unbiased. This isn't a passive hope, it's a proactive and continuous effort. The system needs to be actively designed and rigorously tested to mitigate any unfair outcomes or discrimination. This is particularly crucial when dealing with sensitive attributes like race, gender, age, or socioeconomic status. This isn't just a technical accuracy metric. It involves a deep, ongoing assessment of its societal impact and ensures equitable treatment for all users.
Fairness is key. What else?
Third, it should ideally be interpretable, often referred to as explainable AI, XAI. As we just touched upon, especially for applications making critical decisions, the ability to understand the rationale or the key factors behind the AI's decisions is vital. It builds essential trust, it facilitates necessary human oversight, and it enables thorough auditing or challenge processes.
People need to understand the why.
They often do, especially when the stakes are high. Fourth, it needs to be user-friendly. This means designing the AI with the end user squarely in mind, ensuring intuitive interaction, clear communication about the AI's capabilities, and just as importantly, transparently conveying its limitations. If users can't effectively interact with or understand the AI, its inherent value significantly diminishes, no matter how technically brilliant it is.
Easy to use and understand.
Exactly. Fifth, it must be secure. A truly well-built AI is robustly protected against a whole range of malicious threats. This includes sophisticated adversarial attacks where tiny, often imperceptible changes to input data can trick the AI into making wrong decisions. It includes data poisoning where malicious data is intentionally introduced to contaminate the training set. And it includes other security vulnerabilities that could manipulate its behavior or compromise the underlying data. It needs to be resilient to both accidental errors and deliberate malicious intent.
Secure against attacks. And the last quality.
And finally, it should actively mitigate unexpected outcomes. This refers to ensuring predictable behavior, even when the AI encounters novel data or situations that fall somewhat outside its initial training distribution. This indicates a resilient and robust design that prevents surprising, unintended, or potentially harmful emergent behaviors. It's about ensuring the AI doesn't suddenly go off script in unexpected ways.
Those are definitely the ideal qualities to shoot for. But I imagine getting there isn't always smooth sailing. What are some of the most significant challenges that typically crop up in this build and or adapt phase, especially during testing, that can make achieving that real-world reliability so difficult? It sounds like it could be a constant battle against unforeseen complexities.
You're absolutely right. This phase is frankly rife with significant, persistent hurdles. It's where a lot of the hardest work happens. One of the most profound and critical challenges is bias in models. Even if you start with meticulously cleaned and ethically sourced data, biases can subtly creep in, maybe through the algorithm's design choices or the way features are engineered for the raw data, or even just how the model implicitly learns to interpret complex patterns from real-world data, which itself might contain historical biases.
Bias is hard to root out.
It's incredibly difficult to identify and correct these often deeply embedded biases because they can lead to consistently discriminatory or unfair outcomes against specific demographic groups. This demands specialized fairness testing, often employing diverse data sets and fairness-aware metrics, and requires continuous ethical review to ensure an AI doesn't perpetuate or even amplify existing societal biases like those historically observed in some hiring tools or early facial recognition systems.
Like the facial recognition issues.
Exactly. Early facial recognition algorithms notoriously had significantly higher error rates for individuals with darker skin tones, which was a direct result of biased training data lacking diversity. Another pervasive challenge is model drift. This is a phenomenon where an AI model's performance subtly or sometimes not so subtly degrades over time once it's deployed and operating in a live environment.
Why does that happen?
Because the real-world data it processes in production gradually, or sometimes rapidly, diverges from the data it was originally trained on. Think about that weather prediction model trained on historical climate patterns. If climate change significantly alters those patterns over time, the model will inherently become less accurate unless it's continuously retrained or adapted.
The world changes, the model needs to keep up.
Precisely. It's like a meticulously tuned car engine that performs perfectly in a controlled lab environment, but then struggles and loses efficiency when faced with the very terrain's fuel qualities and driving conditions of the real world.
Okay, so bias and drift are big ones. What else?
Well, it's also absolutely crucial to dedicate significant effort to identifying and testing the limitations of the model. It's simply not enough to know what an AI system can do with high accuracy. You must deeply understand and meticulously document what it cannot do, or where its performance might degrade significantly.
Knowing its boundaries.
Exactly. This involves rigorously pinpointing scenarios where its accuracy might plummet, or where it might generate incorrect, nonsensical, or even harmful outputs. Knowing the precise boundaries of its capabilities and the specific context in which it performs suboptimally is key to safe, transparent, and responsible deployment. You need to know when not to trust it.
And data issues can still bite you here.
Oh, absolutely. Reiterating from the previous phase, inaccurate or incomplete data issues are major problems that will inevitably manifest right here during model building and testing. Any lingering problems from the data collection and processing phase, whether it's systemic errors, critical gaps in the data, or mislabeled examples in the training set, will inevitably lead to errors and flawed learning in the model itself. And these issues can be incredibly difficult and expensive to debug at the model level, which really underscores the profound interconnectedness and the cascading impact across the entire AI lifecycle. Get the data wrong, and everything downstream suffers.
It all connects.
It all connects. A truly proactive and essential approach, especially for critical systems, is failure mode analysis. This is the systematic process of identifying all the potential ways an AI system could possibly fail or produce undesirable outcomes.
Thinking about everything that could go wrong.
Exactly. You try to anticipate everything. You categorize these potential failures, from subtle misclassifications all the way up to catastrophic system shutdowns.
Yeah.
And then you design specific targeted tests to either prevent them from occurring in the first place or to mitigate their impact if they do happen. For AI and safety-critical systems, like autonomous vehicles or complex medical diagnostic tools, this proactive identification and testing of every conceivable failure point is absolutely vital for ensuring safety and reliability.
What about unexpected behaviors? Things you didn't plan for?
That's another key challenge. Detecting unlisted features or unintended consequences. AI models, particularly complex ones like deep neural networks, can sometimes exhibit emergent behaviors. They might develop unexpected vulnerabilities or even learn to perform tasks that were never explicitly programmed or anticipated during their development.
The AI gets creative.
Sometimes, yes. These emergent behaviors can be surprising, occasionally beneficial, but often problematic or even risky. Thorough testing needs to look specifically for these unanticipated outcomes that could arise from complex interactions within the model itself or with its broader operational environment.
What if you just don't have enough data?
That's another significant challenge. Testing with less data. In certain niche applications, perhaps in specialized medical imaging for rare diseases or very specific industrial processes, large volumes of high-quality training data might simply not be available. This scarcity poses a huge challenge for training robust, generalizable, and highly reliable models that can perform accurately on new, unseen inputs without extensive data to learn from. This requires innovative techniques like transfer learning or using synthetic data generation, but it remains a considerable hurdle in many fields.
And for safety systems, testing those must be incredibly hard.
Extremely hard. Finally, for safety-critical AI systems, there's the incredibly demanding and resource-intensive task of impersonating or replicating specific safety features. This means rigorously testing that safety features think about the emergency braking system in an autonomous vehicle, or the fail-safe mechanisms in an AI controlling a nuclear power plant function correctly under all possible conditions,
All possible conditions.
including rare edge cases, extreme environmental factors, sensor failures, and even simulated malicious inputs designed to try and fool the system. This often involves highly specialized simulation environments, exhaustive real-world testing, where feasible and safe, and extensive formal verification protocols to build sufficient confidence.
Wow. The build and door adapt phase clearly determines the actual behavior, the capabilities, and crucially, the limitations of the AI that you interact with every single day. Understanding these inherent challenges really helps you, the listener, appreciate why AI isn't always perfect, why that continuous improvement and iterative refinement we talked about is absolutely necessary, and why ethical considerations are so deeply embedded and need to be continuously reevaluated throughout the development process.
It's a constant balancing act.
It really is. It's about recognizing the incredible engineering feats and the complex problem solving happening behind the scenes. It's definitely far from simple coding.
Phase 4, make available for use deploy.
Okay, so we've meticulously planned it. We've gathered and prepared our data with the utmost care. We've built and rigorously tested the model against every conceivable challenge we could think of. Now what? This feels like the moment where all that painstaking work truly comes to life. It's time for the AI to make available for use or, to deploy it.
Showtime, in a sense.
Showtime. This is where the AI graduates from the controlled environment of the development lab and steps out into the unpredictable, dynamic, real world.
That's precisely right. And if we connect this back to the bigger picture, the overall life cycle, successful deployment is far, far more than just the technical act of flipping a switch.
Much more involved than just turning it on.
Much more. It involves an intricate dance of careful integration with existing systems, establishing robust continuous monitoring processes, and executing effective change management right across the organization. This phase is where the AI moves from that predictable, controlled environment of the lab into the messy, unpredictable variables of the real world. And that transition needs to be handled with extreme strategic care to avoid potentially serious, unforeseen pitfalls.
Okay, so tell us more about those deployment strategies. Is it usually a big bang approach where it's released everywhere all at once, or is it typically more of a cautious, maybe incremental rollout? What determines the best approach?
For most responsible AI deployments, particularly those for critical or high-impact systems, the approach is decidedly cautious. They almost always begin with a piloting phase, rather than jumping straight into an immediate full-scale live production launch.
Piloting first, why is that so important?
It's a critical distinction that significantly minimizes risk. While the ultimate goal is full live production, piloting involves deploying the AI in a carefully controlled, limited environment first. This might mean releasing it initially only to a small, select group of internal users, or perhaps deploying it in a single limited geographical area, or even launching it with constrained functionality just for a trial period.
A test run in the real world?
Exactly, a controlled test run. The crucial role of piloting is multifaceted and really invaluable. It allows you to gather essential real-world feedback in a low-risk setting. It helps identify unforeseen issues or bugs that might not have surfaced during even the most rigorous lab testing. And perhaps most importantly, it lets you validate performance metrics within an actual operational context.
Because the lab isn't the real world?
It never is, not completely. A synthetic test environment, no matter how well designed, can never perfectly replicate the full spectrum of real-world usage patterns, the immense variability of live data, or the nuanced, sometimes unpredictable behaviors of human users. Piloting provides that invaluable opportunity to refine and fine-tune the AI based on practical usage patterns before you attempt a broader rollout.
So piloting often leads to a phased approach.
It often does. This typically leads directly to a strategy of phased rollout versus immediate deployment. Now, for less critical systems, or maybe those with very limited potential impact if something goes wrong, a rapid full-scale deployment might be acceptable. However, for the vast majority of AI solutions, particularly those interacting directly with customers or impacting core business processes, a phased rollout offers significant strategic advantages.
Like rolling it out region by region.
Exactly. It could mean rolling it out region by region, or perhaps to one specific user group at a time, or maybe incrementally activating different features over a period. This phased approach allows an organization to carefully manage risks, learn incrementally from each initial deployment wave, and address issues as they arise without impacting the entire user base or the organization's whole operational infrastructure all at once. It's a measured, strategic approach designed to minimize disruption, maximize the chances of success, and continuously refine the AI based on live feedback.
Okay, so once an AI solution is out there, even in a limited way, it needs to play nicely with everything else the organization uses, right? What are the key considerations around integration and compatibility with an organization's existing systems? That sounds like it could be a real potential headache if not handled correctly.
You've highlighted a major potential headache, absolutely. One of the most significant challenges, and therefore critical considerations during deployment, is ensuring the new AI solution fits smoothly and seamlessly into an organization's existing IT infrastructure, its broader software ecosystem, and its established day-to-day business processes.
It can't be a standalone island.
Precisely. This requires meticulous planning for seamless integration with existing data flows, ensuring compatibility with current user interfaces, and enabling smooth interaction with various back-end systems. If an AI solution operates in isolation, stuck in its own silo, its potential value is significantly diminished, and it can quickly become an ongoing operational burden rather than a helpful asset.
What happens if integration goes wrong?
Well, a poorly integrated AI can indeed cause significant operational headaches. It can lead to data inconsistencies between systems, create frustrating workflows for users, and trigger widespread user resistance. So, robust strategies must be in place before deployment to minimize any disruption to ongoing business. The new AI shouldn't break existing systems, create new, isolated data repositories, or fundamentally disrupt established workflows that people rely on.
Planning for smooth integration is key.
Absolutely. This foresight and careful integration planning prevent costly rework down the line, avoid frustrating employees and customers, and ultimately prevent potential project failure. For instance, if an AI is designed to automate aspects of customer service inquiries, it needs to integrate perfectly with the existing customer relationship management, CRM system, the internal knowledge base, and all the current communication channels, rather than forcing customer service agents to awkwardly jump between disconnected, clunky tools. User adoption really hinges heavily on this seamless experience.
And security, of course, we keep coming back to it. It's a constant, evolving concern throughout the entire life cycle. Does deployment change how we need to think about AI security? Does the target somehow shift once it's live and interacting with the world?
It absolutely reinforces that security is an ongoing, continuous commitment. It certainly doesn't end with development or initial deployment. Once deployed and operating in the real world, AI systems, just like any other piece of software or IT infrastructure, remain active targets for various threats.
The threats don't stop at deployment.
Not at all. Continuous vigilance against new and emerging threats, as well as evolving vulnerabilities, is absolutely crucial. This means implementing and maintaining robust systems for ongoing monitoring for anomalies, detecting sophisticated adversarial attacks, where attackers subtly manipulate inputs to trick the AI, identifying potential data poisoning attempts, and recognizing any other methods that could manipulate the AI's behavior or compromise its underlying data. This proactive, real-time threat detection is paramount.
And the supply chain, that's part of security too.
Yes, absolutely. Furthermore, AI supply chain security becomes even more critically important at the deployment phase. We briefly touched on this earlier, but it's vital to secure the entire AI supply chain. This very often includes components from third-party models, data acquired from external providers, and services hosted on cloud infrastructure.
You need to trust all the pieces.
You do. Vulnerabilities or compromises in any part of this extended supply chain can directly impact the integrity, security, and even the ethical behavior of the deployed AI system. This necessitates continuous monitoring of vendor security postures, conducting regular security audits of all third-party components, and establishing robust contractual agreements with all parties involved, detailing security responsibilities and incident response protocols.
Yeah.
You need unwavering confidence that every single component you're integrating is secure and trustworthy.
And this all feeds into monitoring.
It ties directly into the necessity of continuous monitoring. Automated and manual monitoring of the AI system's performance, its security posture, and its ethical compliance in real time is simply non-negotiable for any responsible deployment. This involves constantly tracking for anomalies in performance, detecting model drift as it occurs in production, ideally before it significantly impacts outcomes, identifying potential adversarial attacks, and recognizing any unexpected or undesirable behaviors before they can cause significant harm or reputational damage.
Like catching problems early.
Exactly.
Yeah.
For example, if a recommendation engine suddenly starts recommending wildly inappropriate content, continuous monitoring systems could flag that anomaly immediately, allowing for rapid investigation and intervention.
That's a lot of technical oversight and vigilance. But what about the human aspect? AI often fundamentally changes how people work, right? It affects roles and processes. How do organizations effectively manage that transition and ensure their workforce embraces, rather than resists, the new AI tools?
This is precisely where comprehensive change management comes in, and it's arguably one of the most overlooked yet absolutely critical aspects of successful AI deployment.
The people side.
The people side, exactly. The introduction of AI can significantly alter existing job roles, redistribute responsibilities, and fundamentally transform workflows within an organization. There's an undeniable need for proactive, well-communicated strategies to prepare the workforce for these changes, to openly address concerns, such as the very real fears people might have about job displacement or the perception of being replaced by a machine, and to build genuine confidence and competency in using the new AI tools effectively.
How do you do that?
Well, it often involves things like strategic reskilling programs for employees whose jobs might change, carefully redefining roles to leverage human-AI collaboration rather than outright replacement, and clearly communicating the benefits of the AI for both the business and its people, emphasizing how it can augment human capabilities and maybe remove tedious tasks.
And training is part of that.
Absolutely vital. Related to this, and crucial for adoption, is staff training and upskilling. It is paramount to provide adequate, tailored training to employees on how to effectively use the new AI systems, how to accurately interpret their outputs, knowing when to trust them and when to question them, and crucially, how to understand their inherent limitations.
Training for everyone involved.
Yes, this also extends to providing specialized training for IT and security teams on how to effectively maintain, troubleshoot, and secure the AI in its live operational environment. Without proper training, even the most sophisticated AI will fail to achieve its potential simply because employees don't know how to integrate it effectively into their daily tasks, leading to underutilization or even outright rejection of the tool.
And getting feedback from users.
Crucial. There's the imperative of user empathy and establishing robust feedback loops. Organizations must actively solicit, genuinely listen to, and meticulously incorporate feedback from the end users who are actually interacting with the AI day to day. User experience, UX research, usability testing, and establishing clear, accessible feedback channels are vital for continuously refining the AI, making it more intuitive, and ensuring it truly meets real-world needs and workflow demands. This iterative feedback process, driven by actual user experiences, is key to improving user adoption, enhancing satisfaction, and ultimately ensuring the AI's long-term efficacy and value.
Okay, and finally, managing changes to the AI itself once it's live.
Yes, and foundational to ongoing management, there needs to be a formal change management process for the AI system itself, as emphasized in our source material from AAISM. This is a structured approach for handling all updates, modifications, and even emergency changes to the AI model or the overall system once it's live in production.
What should that process include?
It should meticulously include several key elements. First, rollback capabilities. The absolute necessity of having the ability to quickly and reliably revert to a previous, stable, and known good version of the AI model or system if critical issues or unforeseen problems arise after a change. This is a vital safety net, allowing organizations to quickly recover from unforeseen problems without catastrophic disruption. Second, impact assessment. Thoroughly evaluating the potential consequences and ripple effects of any proposed change before implementation, considering not just the technical implications, but also the potential operational, ethical, and compliance impacts across the board. Third, version control. meticulously tracking and documenting all changes made to the model, its training data, its configuration, and the underlying code. This ensures complete traceability and allows for efficient debugging, auditing, and historical analysis if needed. Fourth, revalidation. Rigorously rerunning comprehensive tests and verifications after any change to ensure the AI's performance, security, and ethical compliance are maintained at the required levels, and crucially, that no new unintended issues or regressions have been accidentally introduced. And finally, communication. Clear, consistent, and proactive communication with all affected stakeholders, internal teams, end users, maybe even external partners, about upcoming changes, their intended benefits, and any potential impacts or adjustments required from them. This builds trust, manages expectations effectively, and facilitates smoother transitions.
This deployment phase is truly where you, the user, directly interact with AI on a daily basis. Understanding this intricate process sheds significant light on why updates happen, why your feedback is actually incredibly valuable to the teams managing these systems, and why organizations need these robust systems in place to ensure AI is not just launched, but continuously and responsibly managed throughout its entire operational life.
It's a living system.
It powerfully underscores that AI is indeed a living, breathing system that requires ongoing care, constant attention, and continuous adaptation, much like any other critical business asset or infrastructure. Outro.
So we've taken a truly comprehensive deep dive today into the AI lifecycle. It's a complex framework, definitely, but an incredibly important one that meticulously guides the journey of artificial intelligence from its very first conception, that initial idea, all the way through to its eventual retirement.
Yeah, we've covered a lot of ground. We really have. We've meticulously covered everything from the initial strategic planning and foundational design, through the painstaking collection and rigorous processing of data, to the intricate engineering process of building and adapting AI models, and finally landing on that crucial multifaceted phase of making these systems available for use and deploying them responsibly out there in the real world.
And what's truly fascinating here, I think, if we just step back for a moment, is that the AI lifecycle is far more than just a technical process or a series of sort of engineering checkboxes.
Right. It's bigger than that.
It really is. It's a
Yeah.
continuous dynamic commitment
Mm.
to responsible innovation.
Mm.
Every single stage, as we've explored today, is deeply intertwined with critical ethical considerations, robust risk management strategies, and perhaps most importantly, the indispensable human element that ensures these powerful tools actually serve humanity effectively, fairly, and securely.
Mm.
It's really about cultivating technology that truly enhances rather than diminishes our collective capabilities and our core values.
Absolutely well said. To maybe bring it all together, here are some key takeaways for you, the listener, from today's deep dive. First, remember that AI development is fundamentally a highly structured, iterative process. It demands ongoing attention, continuous adaptation, and constant vigilance. It's really far from a set it and forget it kind of solution.
It requires constant tending. Second, the quality, the integrity, and the ethical considerations surrounding data are absolutely foundational. They directly and profoundly influence the fairness, the accuracy, and the overall trustworthiness of any AI system built upon them. Remember, garbage in, garbage out isn't just a cliche. It's a critical, often costly warning in the world of AI.
Third, continuous testing, vigilant monitoring, and proactive adaptation are absolutely essential for an AI system to remain reliable, secure, and beneficial in a constantly changing world. And AI is always learning and potentially evolving, and so too must the robust systems and the human oversight that manage it.
And finally, the human element, ranging from those diverse, multidisciplinary teams involved in the initial planning and development, all the way through to the critical role of end users providing crucial feedback in live environments, is absolutely integral to building, maintaining, and ensuring responsible AI. Human oversight, ethical deliberation, and user-centric design need to be woven into every single thread of the AI lifecycle.
So, as artificial intelligence continues to deeply integrate itself into pretty much every facet of our lives, from personalized recommendations to critical decision-making systems in areas like healthcare and finance, here's a final thought to leave you with. How can your newly enhanced understanding of this meticulous AI lifecycle empower you to engage more critically and perhaps more thoughtfully with the AI systems that shape your daily interactions and, increasingly, your future?
Maybe consider the broader ethical and societal implications of AI beyond just its immediate utility or convenience.
Exactly. And remember that behind every powerful algorithm is a carefully managed, living system, one that's constantly evolving and demands our ongoing attention and critical thought.